it's the meta-analysis video. Even I don't want to be here. Help! My supervisor made me do a meta-analysis. Yeah, look, I know. There's nothing we can do, but we can look at this lovely slideshow, I was meant to say. A systematic review and a meta-analysis are related but distinct components of the research synthesis process. But let's have a look at some key differences between them, okay? A systematic review is a comprehensive and structured review of the available evidence on a specific research question or topic. It involves systematically searching, selecting, and critically appraising relevant studies. A meta-analysis is a statistical technique used within a systematic review to combine and analyze quantitative data from multiple studies, producing a summary estimate of the overall effect. Okay, here's some more differences. Okay. Systematic review. Primary goal: provide a thorough and unbiased synthesis of existing evidence by identifying, evaluating, and summarizing relevant studies. Give me the highlighter back. Are you the highlighter? You're not the highlighter. Okay, review out. There we go. Meta-analysis, okay? Main objective is to quantitatively pool the results of individual studies to generate a more specific and robust estimate of the treatment effect or outcome. I can't even read. In addition to the narrative synthesis, meta-analysis incorporates statistical methods to combine numerical data, allowing for quantitative synthesis and a more precise estimation of the treatment. So here's some more differences, okay? Systematic review describes and explores that word that I can never pronounce qualitatively, identifying potential reasons for variations in study designs. Meta-analysis quantitatively assesses this word. Statistical tests may explore source of variation through subgroup analysis or meta-regression, okay? Don't worry, it's going to get very exciting soon enough. Well, mildly exciting very soon. Systematic review, okay? You're looking at publication bias and you're discussing the implications of selective reporting. Meta-analysis, you're going to have people like funnel plots, Egger's test, that sort of stuff, okay? There's two more there, okay? Typically presents a narrative synthesis, summarizing findings in a descriptive manner, presents quantitative summary measures such as forest plot, demonstrating the effect sizes of individual studies and the overall pooled estimate, okay? In all the years I've been running my business and having people come to me with their thesis looking for help, the people with sort of the most frazzled of people are those doing these type of studies, because on a surface level they do look very intimidating. But there is a sort of a code for breaking through them, and it is a lot easier to navigate them once you realize what that code is. But I do get it. Like, I do understand that, like, you know, there is a bit of like, oh my god, I have to switch off for this, because it is quite boring. It is quite, you're back in school listening to your maths teacher, you're back in school listening to any teacher. If you've had like that type of experience and that type of learning style. So I do get it. Like, I do understand, like, you know, sometimes people say, like, you know, I'm a little bit unserious at times when I'm talking about particular topics, but that's okay. Look, I mean, I'm not for everyone, you know. I'm gonna get off this page before I start drawing on the thing. Look, please, I still need help. Look, I get it, okay? I'm here to help. Conducting a meta-analysis for your thesis involves statistically synthesizing data from multiple studies to draw meaningful conclusions. And I'm going to give you 5 tips, okay? Clearly define your research question and inclusion criteria. Clearly articulate your research question or hypothesis. This will guide the selection of studies for inclusion in your meta-analysis. Develop specific inclusion and exclusion criteria for selecting studies. Clearly define the characteristics of studies that will be considered for the meta-analysis to ensure consistency. Design a comprehensive and systematic search strategy to identify all relevant studies. Search multiple databases, use appropriate keywords, and consider both published and unpublished literature. Independently assess the eligibility of studies based on predetermined criteria. And you basically clearly document the selection process and provide a flowchart outlining the study selection. Okay? Everyone's still awake? Evaluate the I can never say the word. Among the selected studies, statistical measures such as I2 and Cochrane's Q test can help assess the degree of variation between studies. If significant exists, explore potential sources through subgroup analysis or meta-regression. Consider conducting sensitivity analysis to assess the robustness of your findings, okay? Adhere to established reporting guidelines such as PRISMA. This enhances the transparency and completeness of your meta-analysis. Clearly present the characteristics of included studies, the methods used in the meta-analysis, and the results. Include a forest plot or a graphical representation to display effect sizes and confidence intervals. Assess and address publication bias, which can arise if studies with significant results are more likely to be published. And then using funnel plots, Egger's test, or the trim and fill method, okay, for bias. Conduct a quality assessment of included studies. Consider using tools like the Cochrane Risk of Bias tool for randomized control trials, or the Newcastle Ottawa scale for observational studies. Guys, I'm so sorry. That was so boring. I don't know what I'm. Yeah, look, I have to do it. You know, hang on. The Bill Mallon industrial, PowerPoint complex has to continue on. So I have to do PowerPoints for everything. And some of them are going to be more exciting than others. Some of them are going to be more engaged. I'm going to look really happy. I won't be wearing a coat and freezing, doing meta-analysis. But I'm always here for everyone, you know. And even though I may not like doing these particular things, if you are doing one of them, you know, I will help you as best I can. But I'm not always switched on for certain topics as I am for others. And that's okay, you know, I'm going to be honest with you. Okay, look, let's have a look at an example, okay? Okay, so imagine we're conducting a meta-analysis to estimate the overall effect of a specific treatment. So let's call it just treatment X, whatever it can be, okay? On blood pressure reduction based on the results of several randomized controlled trials, okay? So like the systematic review, I'm going to go through a few steps. So the first one, let's get a research question going. What is the overall effect of treatment X on blood pressure reduction across multiple RCTs? Okay, so now we have a research question. So now we're going to have a look at getting the literature. So we have 5 studies here, okay? So here's the control, and then there's the treatment, okay? So let's say we identify 5 relevant RCTs that meet our inclusion criteria. For each study, we extract the data on the mean reduction in systolic blood pressure and its standard deviation for the treatment X group and the control group, okay? So that's what that would look like initially. So calculate the effect size for each study. In this example, we'll use the mean difference in SBP reduction between the treatment X group and the control group, okay? Please appear on, oh, there we go. Weighting studies, okay, so assign weights to each study based on its precision, inverse variance, given more weight to studies with larger sample sizes or lower variability. And then number 5, calculate overall effect size. Calculate the overall effect size by pooling the individual effect size using a weighted average. The most common method is the inverse variance method. Assess, they should get rid of this word, I cannot pronounce it. Assess the hedron, not even going to bother, among studies using statistical tests. So Cochrane's Q-test, I2 statistic. If it's present, explore potential sources through subgroup analysis or meta-aggression. So here's the final tips here, okay? Or final steps. Sensitivity analyses and publication bias, okay? So that's going to help you explore the impact of excluding specific studies. Assess publication bias using funnel plots and statistical tests, so Egger's test there. And then obviously present results, and that's going to be your thesis. Sorry, no, forget I said that. So present the results in a forest plot showing the effect size and confidence interval for each study along with the overall pooled effect size. When you have all that, then you present the results of all of it in your thesis. So Shanae, as they say. Yeah, look, I mean, I don't like that sort of stuff. I'm not a big fan of. I work with a lot of people doing statistical analyses, but I always tell them I'm not a big fan of it. I know how they're supposed to be done. I know how it's supposed to be laid out. I know where you get all the top marks for, but don't expect me to be interested in anything to do with maths. My maths teacher, if he ever does watch this, will be looking at me going like, how the hell is he? What's he doing talking about maths? One of the most useless students I've ever had. It's just not my forte, you know. But I'll do a slideshow on it as I did here, and I'll give you the top tips, top tricks. As always, my best tip I can give anyone is look at other people's thesis. So go onto Google and put in meta-analysis, thesis, masters, or PhD, and then put the word PDF after it, put it in inverted commas, the whole thing, and then hit enter, and then you get a whole list of stuff. And my greatest advice to anyone is follow what's been done before, because that's all they want. They just want to see that you haven't strayed too far from the format and the structure. Bring your own contribution into, which is the results or your research question you're doing, but the actual structure, like the evidence table, comparing and contrasting studies, putting the findings into a particular format, which is what you're going to see in those other people's thesis, and then just concluding it, and that's all you're really looking for. And don't make it overly complex. It is boring. You may love it, okay, but I'm just telling you, I don't love it. I don't particularly like anything to do with maths or statistics, but I won't abandon you in your time of need. So if you're ever looking to do, now this is different from quantitative studies. I'm not talking about those type of studies. I'm more talking about like the really, the heavy going statistical ones. So as I say multiple times, qualitative, quantitative, mixed methods, they're my systematic reviews. They're my main bread and butter. So that's the main thing I usually help correct and fix. But when people come to me with like very heavy statistical thesis, I always tell them, I don't condone what you're doing. I think it's an affront to humanity to bring more maths into the thing and remind me of school. But look, I'm here for you to help you. So hopefully this slideshow was very helpful. Probably a bit scattered, but that's okay. I'm a bit of a scattered individual. But yeah, if you got something from this, leave a like. If you didn't, leave a dislike, I suppose. And if you know someone who is going through it, suffering, maybe you're the husband or the wife or whatever of someone who's doing something like this, and you said, you know what, this insane person I found on YouTube might be able to help my significant other. Just grab the link and blast it over to them, okay? So yeah, that's enough for now, and I'll see you out there.